Okay, this is Unit 2, Lesson 14, vocabulary review. How is pi related to the circumference and the diameter of a circle? So if you recall in the lesson, I think it was lesson 4 on circumference and area of a circle. They first explained where pi came from. The number pi comes from the ratio of two numbers. So first of all, before we can get to that, do you guys remember the definition of diameter or definition of circumference? Or the formula for circumference. There's two formulas. Can you give me one of those two formulas? Fatima. Okay, so circumference equals pi times the diameter. Okay, and there's another formula, right? What's the other formula for circumference? Just got it. Lauren?
Circumference equals pi times radius divided by 2.
Not divided by 2.
Square.
No, you're thinking area. Remember, the relationship between diameter and radius is radius times 2 equals the diameter. So 2 times the radius times pi is the other formula, right? And the books will give you different ways to write this. You can say 2 times pi times r, 2 times r. It's all multiplication, so it doesn't matter the order. Now, back to my question about what is pi. How is it related to circumference and diameter? How are they related? Well, let's take this equation and let's see if you guys remember, how do we solve for pi? How would I get pi by itself?
You divide.
I divide by what?
2.
No, over here. How do I get pi by itself over here?
Oh,
What's with pi?
3.
Look over here. What's with pi? No, look. Circumference equals pi times diameter. So what's on the side with pi? Diameter. And what's happening between diameter and pi? Multiply. So what happens if we get pi by itself? What do we have to do? Divide by diameter. So nice. So if I take and divide both sides by diameter, then my diameters cancel, and then on the left-hand side, I'm left with the ratio. Okay, do you see that? And then my diameters will cancel out. Boom, boom. So then I get this formula. I get pi is equal to the circumference divided by the diameter. So pi is the ratio of circumference and diameter. So here's the relationship between circumference and diameter that gives us pi. Do you guys understand? Okay. So from this is how we get our formulas for circumference. Now, for number 2 and 3, we're going to find the area of each circle. Somebody gave me earlier, mistakenly, the area instead of circumference. What is the equation for area? Who remembers what the equation for area is? I heard it a minute ago. I think, Sergio, what's the area formula?
Pi times radius squared.
Nice. So area equals pi times the radius squared, right? But did they give me radius in these problems? Do we have radius? No, and I warned you, be careful about this. Some of you guys messed up on this with the quiz. They're not giving you radius. What are they giving me? The diameter. And the area formula doesn't have diameter in it, so we have to convert over. So we're going to use this for both. So what would my radius be? If my diameter is 15 meters, then my radius equals what? Somebody tell me what my radius is equal to. Richard? It's half the diameter, or 7 5/10 meter. So that is what we're going to use for radius in my formula. Now, some of you forgot the number we used to approximate pi. What did we use to approximate pi? It's about equal to 3 and 1400ths. Now, pi is an irrational number, and irrational numbers are what? Go ahead. They do not repeat, and go ahead.
Can't be put into fraction form.
You can't write into fraction form because that's a rational number, but they don't repeat and they don't end or they don't terminate. So they go on and on forever, but and none of the digits repeat. That is an irrational number. Okay? So we had a number that we used to approximate it, 3 and 1400ths. That's what we used for pi. Okay? Do you have a question?
Yeah. Wait, so how did you get 7.5?
Because they gave me the diameter in the drawing, and it's 15 meters. The radius is only from the center to the edge. The diameter is all the way across through the center. Do you understand why it's half? Right. Right. So you had $15. What's half of that? Well, we both had $7. That gives you 14, right? So we have $1 left over, 50 cents. So $7.50 each, right? So do you see where it comes from now?
Yeah.
All right, so now for R, we have R equals 7 and 5/10, right? So 7.5 meters, and I'm going to put parentheses around that. So you guys need to square 7.5. I need you guys to do this because this is where a lot of you are messing up. When I graded the quiz, you're messing up on the calculations. So multiply 7.5 to itself so you can find radius squared. So when you find radius squared, what'd you get? Who calculated the radius squared? What is that?
I got 52.
56 and 2500.
I heard a couple different answers. What do you think it is, Isaiah? 56 and 2500ths. So not only is it 56 and 2500ths, it's meters to the what power? Second power. So don't forget about that. So I still got to multiply radius squared to pi now. My approximation for pi. So can you guys go ahead and do that? When I multiply that out, what do I get? Caden, could you speak up?
I got 169.
176 and 625 thousandths. Do you see where you slipped up?
Yeah.
And it's meters squared. But this is where some of you guys messed up also. You have to round to the nearest unit. They said the nearest unit, and that means the nearest whole. So what's that going to be rounded to the nearest whole? What's that going to be? Denia? 177 meters squared. And the reason is we're trying to round to this place, so we have to look at this place. And so if it's 5 and up, I have to bump that up. If it's not, I just drop everything off. Okay? So can we look at this next problem over here? What is my radius square going to be? What's my radius going to be over here? Right. Since diameter equals 12 meters, the radius is just half of that, so that's 6 meters. That means over here, I'm going to raise 6 meters to the second power. And instead of pi, what do I get instead of pi? I'm going to use something to approximate.
It's just the second power.
Right? So I'm going to multiply this. I got to raise it to the second power. Okay. And what is 6 meters to the second power?
36.
It's going to be 36 what? What's my units?
Meter.
It's the meters to the square power. So 6 times 6 is 36. Meters times meters is meters to the second power. So we have 36 meters squared times our approximate value for pi, which is 3 14/100. You guys go ahead and calculate that out. A little bit easier than the first one. Denia, what'd you get?
113 and 400.
113 400ths. And what are the units? Meters squared. We need to round to the nearest whole unit, right? So class, what's the nearest whole unit going to be? Just 113. Because that's a 0 next to the 3, right? So it's not enough to bump the 3 up, right? So it just says 113 meters squared. So that's our approximate value for the area of the circle. Okay? I need you to know how to do this because it's important for what we're doing on Monday. Okay, I'm going to go ahead and read this to you. Since I want to make this the video for the class channel. What you'll learn: to find the volume of prisms and cylinders. New vocabulary: volume, cubic unit. Why learn this? Many storage silos are shaped like cylinders. You can use volume formulas to find the amount of storage space inside a figure like a silo. Do you guys know what a storage silo is? No. Have you ever seen at a farm? You might have a big old barn, right? And then they're giant cylinders, right? And it's a grain silo. And basically what happens, if you see someone up close, you might see that they have numbers on the side of the building. And so however much grain they have inside, they can calculate how much grain they have with the volume of crops they have. Does that make sense? So a grain silo, or a silo, it's shaped like a cylinder. That's where they store their crops in a grain silo. It's pretty easy to find online if you want to look up what they look like. All right, so the reason why we want to know this is earlier we were talking about area. Now, area, the units were square units, right? So when we talked about a shape, we were saying how many squares will it take to fill up this shape, right? Two-dimensional shape, second power. Now we're talking about, hey, I have a container. How many cubes can I put in that container? So let me give you an example. If I gave you a task and I said, hey, I'm going to give you a big bag of dice. Dice are what kind of shape? They're cubes, right? What I want you to do is I want you to count how many dice you can use to fill up this shoebox. And so what you would do is you would try to put rows of dice next to each other, and you'd want to fill the entire bottom of the shoebox with these dice, right? But then you'd put another layer on top of it. Does that make sense? And you'd keep doing that until you filled the entire box up with these cubes, and hopefully along the way you've been counting how many dice you used to fill this up. And then you could say, hey, to fill up the volume of this shoebox is about however many dice, whatever the measurements are of a dice. Does that make sense? Okay, but I'm not sure what the measurements are of a dice, but do you guys see we have a cubic centimeter? Do you guys see that? Here's a cubic centimeter, and it's a cube where all the edges are the same measurement. They're 1 centimeter. Do you guys understand? Now, I have a question. Yes?
So at the bottom, the rectangle.
We're going to get to that in a second. All right, so the volume of a three-dimensional figure is the number of cubic units needed to fill the space inside the figure. A cubic unit is the cube with edges 1 unit long. A cubic centimeter is a cube with edges 1 centimeter long. Okay, so take a look at this. We have a rectangular prism here. Okay, so if I put down one of my cubes, okay, and then I make a whole row of them, that would be a row of 10. But how many rows of 10 can I have on the bottom? I can have 4. So on the bottom, it's 10 times 4. So how many cubic centimeters did I have on the bottom layer? 40. Do you guys understand? But I haven't filled up my rectangular prism yet, have I? I can put another layer. So if you look over here to the left, I can put another layer. So if I have 2 layers of 40, how many do I have now? 80. But I haven't filled it up yet because you see the height of my rectangular prism is 3 centimeters. So I can stack 3 of these layers, right? And so my third layer would be another set of 40. So 3 times 40 gives us how many cubic centimeters? 120. Do you guys understand what volume is? Volume is how much space is filled there. How many cubic units can I put inside this object? Does that make sense? Okay, that's very different than a flat two-dimensional shape. Those are squares. How many squares can I fill up to cover the area of this shape? Now we're talking about a container, something that holds something. So here's the key concept of the day. The volume of a rectangular prism. Here it is. Now they're using a different variable. Do you see this B? Okay. That is the variable they're using for base area. And basically what they're saying is, hey, the base, the face that we call the base, we're going to find the area of it. And so what would the base of a rectangular prism be? What's the face that makes the base of a rectangular prism? What shape is that? It's a rectangle. And how do we find the area of a rectangle? Length times width, right? So do you guys see over here the formula for base? Okay. Once you know the base area, then you just multiply it by the height, kind of like what we did over here. Once we knew how many we could fit in the base layer, we just multiplied that by the height. Then we knew how many cubes would go in there, right? So it's the same thinking. So here's what I want you guys to do. I want you to use this formula to calculate. Mr. Cho is building a craft box like the one shown. What is the volume of the craft box in cubic inches? So they're giving you the dimensions. I need you guys to find, first of all, the base area. So that bottom face down here, we need to find B. What's B going to be? 12 what?
Inches.
Not just inches. We're talking about area. 12 inches squared. Okay. Are we good? 12 inches squared. So now we know the base area. What's the height going to be?
5.
The height equals 5. So this is the height. All right? So now we have to replace these into my formula for volume. So I know this script capital B is how much? What's the base area? 12 inches squared. Okay, and I got to multiply that by the height. And what is the height? 5. Now, inches squared, height is a distance. It's just 5 inches. So who can take a guess on what the unit's going to be when I multiply these two things? What units are we talking about? What's my exponent going to be now? Cubed, or what is that number? 3. So it's going to be, what's 12 times 5? 60 inches to the what exponent? Cubed, third power, cubed.
Why is it cubed?
Let me explain why, because that's an excellent question. So we have inches squared, right? And we got to multiply that to inches, right? So we know that inches squared is the same as inch times inch, right?
Yeah.
And we already have an inch over here. So what's inch times inch times inch?
Inch to the 3rd power.
That's inches to the 3rd power. So do you see why it's going to become inches to the 3rd power? Does that make sense? You're going to need to know that better later when we get into some more algebra topics, but I'm just trying to get you guys ready for that. So when we cross that bridge, you already kind of be in that way of thinking. All right. Pretty easy. Volume, right? You guys know the difference between volume and area. Volume is how much can it hold in it. Does that make sense? Now, I want you to think about this. If the height of that prism was double, what would the volume be?
60 times.
So what would my new height be? What would my new height be if it was doubled? 10. So if my height was 10 inches instead of 5, what would my volume be? It would be 120 inches cubed. Now let me get you guys to think about this conceptually. Say I have a box, right? If I stack the same box on top of it so that you couldn't even tell it was 2 boxes, wouldn't that be double the height? Same base, same bases, right? Do you see why it'd be double the volume? You take the same box, you stack it on top, and then, or if, let's say we took the same box and we glued them together so it was 1, right? Didn't you still just double it? Okay, Makeda, what's your question?
Wouldn't you have to multiply the height?
You can.
Wouldn't it be 25?
No. 5, double the height. You're thinking of 5 squared. If we double it, if we're making it twice as tall, it's just going to be 10. You're thinking of squaring something. That's different. Squaring means you multiply it to itself. Okay, so now, guess what we have now? A triangular prism. Remember the sides of every prism is what shape?
Triangle.
They're rectangles, right? Okay, the base is the shape that names the prism, right? The sides are always rectangles. So here we have a triangular prism. Now, do you see where the base area? The base area is the base, which is the triangle. That's the name that gives this prism its name, triangular prism. So, take a look at my question. Find the volume of the triangular prism. Do you see that my prism's sideways now? But be careful, because what's the height still? What's the height still? It's still going to be what? No, what's the height of the prism going to be? Remember what I said? I said if I turn the shape sideways, right? Remember the bases are always the top and the bottom, but sometimes they'll turn it sideways. The length of the rectangles are always the height of the prism. Do you guys remember that from the other day? So what's the height of this prism? That's the...
It would be 3.
What's 4 and 3 have to do with? Isn't that the base? Isn't that the sides, the dimensions of the triangle? Okay, so 4 and 3 are the dimensions of the triangle. That's the base. So my prism's laying sideways. You understand? So the height of the prism is what? It's going to be 6. Now, they turned this sideways to kind of help you find the area of the bases. What's the area of my base going to be?
12 centimeters.
Okay, hold on. You didn't find the area of a triangle. What's the area of a triangle? Who remembers the formula for area of a triangle? That's it, exactly. Did you guys hear that? Base times height divided by 2. Remember, a triangle is half of the parallelogram, right? So the base equals lowercase b times whatever height is divided by 2. But since we already got h, we're going to say length times width divided by 2. And that's going to be 3 centimeters times 4 centimeters, all divided by 2. And what's that give me back? 12 centimeters squared divided by 2, which is 6 centimeters squared. So that's what my base area is. It's going to be 6 centimeters squared. But we need to multiply that by the height, and we just talked about that. What is the height? It's 6 what? Only centimeters, right. Talking about the length of it. So we need to multiply this out. And what is this area of volume going to be when I multiply this out? It's going to be 36 centimeters cubed. Very good. Okay, so now that we have that, figured out, let's answer this question. If the height of the prism is doubled, what is the volume of the triangular prism going to be in the previous example? If we doubled the height, what happens? It'll be 12. The height will be 12, but what's the volume going to be? Well, we're saying instead of 6, it's going to be 12, right? It's going to be 72. 72 what? Centimeters cubed. So the volume is going to be doubled. If the height's doubled, then that's like taking the same prism, stacking it on top of itself, right? Isn't it going to be double the volume? Okay. Now, this is the one that throws some people off. And I made a paper model for you guys yesterday. I made a little bit better one today. So do you guys remember, yesterday we found surface area, right? And surface area comes from the area of the side of the cylinder, the top of the cylinder, and the bottom of the cylinder, right? And the part that was throwing everybody off is, how do we know how long that rectangle is that makes the side? Now, if it's long enough, then when you make the side, it'll completely seal off the side as you put on the circle on the top, right? You guys see that? Okay. But let's just say it's not long enough. Watch what happens if it's not long. Do you guys see my circle right here on my desk? Look what happens. If it's not long enough, is that going to be a very good cylinder? No. What's going to happen? Can I put anything in this cylinder? No, it's going to come right out the side, because the side that makes the curved surface of the cylinder, it's not long enough to close, because it's not the same length as the circumference of this circle. Do you guys understand? So this has to be at least the circumference of the circle in order for us to close up the sides. Does that make sense? So I have a top and a bottom. That's a circle. My side, rectangle that makes the side, has to be at least the length of the distance around the circle, which is the circumference, in order for it to work. Do you understand? So today we're doing something different. Now we're trying to figure out, inside the cylinder, how much can we put inside the cylinder? Yesterday we're trying to figure out, how much do we need to make this shape, to cover this shape? Now we're seeing, how much can we put inside this shape? So that's what we're going to do next. And the thinking isn't much different than what we did in the previous example. You had to find the base area. And what is the base of a cylinder? It's the circle. And how do you find the area of a circle? Pi times the radius squared. So once you know the base area, you just multiply that by the height, and then you know how many cubes will fit inside that cylinder. Do you guys understand? Okay, so here's what I need you guys to do. We're going to calculate the volume of this paint can. There's all the information you need. Let's get cracking.
Can I go to the base?
Okay, so how do we find the base area of this first? We're trying to find the bottom of this cylinder. We're trying to find that. And the formula, we already know it. It's pi times the radius squared. Well, what did we get for pi? What are we using for pi to approximate? 3 and 1400ths. And what are we going to multiply? What are we using for the radius? 4 inches. And all that has to be raised to the second power. So if we raise that to the second power, we get 3.14, or 3 and 1400ths, times what? 16 inches squared. So now I need you guys to multiply our approximate value for pi times 16. So what do we get back? Okay, some of you guys just waited for somebody else to tell you the answer. On Monday, you're not going to be able to do that. I need you to write this out and check to see that you get the same answer. Multiply it. We're almost done. Makeda, what'd you get?
50 and 24 hundredths.
Did you guys get the same thing? Okay. So now we're going to replace this in for our formula for volume. So this is just B. Okay? And we just calculated that. So we got 50 and 24 hundredths inches squared. We got to multiply that by my height. What's the height of this going to be? What's the height of my cylinder?
It's 9 inches.
It's going to be 9 inches. So take the value that we just calculated. We got to multiply it by 9 inches to get the volume of the cylinder. Going to be a lot of regrouping or carrying. Somebody I haven't heard from. Anea, do you have it? Sergio.
452.16 inches.
That's correct, Sergio. 452 1600ths inches to the what unit? What exponent? Third power, right. And then they want us to estimate to the nearest whole unit, right? So the nearest whole number is going to give us what for our approximate value?
453.
No, look, what's next to the ones place? It's a 1, right? And so if it's 4 and below, you let it flow. If that was 5 and up, then I'd bump that up to a 3. Okay, so let's make sure we get that straight. 452 inches cubed. Okay, so almost done. I want you guys to take a look at this problem right here. Now they're trying to trick you. They're trying to trick you because of two things. They're trying to trick you because they turned it sideways, because they want to throw you off on what's the base. And then also, what are they trying to trick you with? They gave you the diameter, right? But we know how to fix that. That's so easy to fix. How do we figure out what we need? What do we need instead of the diameter? The radius. And how do I go from the diameter to the radius? I just take half of it. And you guys know what half of this is. What is the half of 18?
9.
So if the diameter equals 18 centimeters, then we have the radius that equals 9 centimeters. So we need to calculate what B is, right? We're trying to figure out what B equals. And we know B is equal to what? How are we going to calculate that? You got to know this formula by Monday. Come on. How do we find the area of a circle? Come on.
Based on height.
No, you're thinking of a rectangle. Pi times radius squared. So remember, the circle area is pi times the radius squared.
Mansfield Clements, please report to room
Okay.
404. Mansfield Clements to room
So
404.
if we have the value for pi that we use, and we're going to multiply that by the radius, which is 9 centimeters, and we need to square that, right? So we're going to raise that to the second power. That's going to be my value for B, the base area. Okay, well, what is 9 centimeters raised to the second power? It's just going to be 81. So we got pi times 81 centimeters squared okay, and when I calculate that, what do I get back?
254 and 34 hundredths.
Say that again.
254 and 34 hundredths.
Did anybody else get that? Good. So we get 254 34 hundredths centimeters squared. But that's not my answer, is it? I have to do one more thing. What do I have to do? No. This is just the base. This is the area of the circle. I'm trying to find the volume. Look at the formula over here. Here's the formula for volume right here.
Multiply the height.
Multiply by the height. So I got to take that number, 254 3400 centimeters squared, and I got to multiply that by the height. And what is the height of this cylinder?
24.
It's going to be 24 centimeters. Okay? Now, when I multiply that out, what am I going to get back? You guys go ahead and multiply that out. You got it?
530, 460.
No.
Wait, say again. I think you're close.
530.
No, no. Fatima, what'd you get? 6,104 and 1600ths centimeters to the what power? Cubed. Now, they want us to the nearest cubic centimeter, so they want us to the nearest whole number. And so what's that going to be about? Well, yep, 6,104 centimeters cubed. Now, uh-huh.
Before I got 6,104 and 2,600 because
I think you carried and you shouldn't have. That is definitely correct. I'm going to skip this problem. We're going to go to this next page. We're almost done. The number of cubic units needed to fill the space inside a three-dimensional figure is called the what? Volume. Now this one, I think we should have this. It says, how does the volume of a cylinder change if we double the height? So basically what happens, if I take a can and I take the exact same can and I stack it, what just happened? I doubled the volume, right? So you double the volume. Okay, now we're almost done. If you take a look at this, you have a triangular prism. And guess what? You don't even have to calculate the base area. You know why? They give it to you. Do you see that? But they still want you to tell them what the volume is. What's the volume of this triangular prism? It's going to be 60 inches cubed. I don't know why people are moving about because we're not done yet. It's 60 inches cubed. And if you notice, we had the base area given to us. Times the height, which is 3 inches. And that gives us the result, which is 60 inches cubed. Now, the next one threw some people off because they assumed they are given the same information as the first example we just had. Here we have a cylinder. They're not giving you the base area. They want you to find it. How do we find the base area with only the radius? How do we find B? I have radius to the second power. Is that all? What else do I need?
Pi.
Times pi. So let's go ahead and calculate that. It's pi times radius squared. We need to know B before we can get with the volume. We are not done. We still have 5 minutes left of class. Have a seat. Because I promise you, the next time I see you, I'm going to get that time back. And if that means during lunchtime, that's what's going to happen. So we already know what pi is. What is pi? Okay. And then we have the radius, which is what? It's 5 centimeters. And so what would the radius square be? What would 5 centimeters squared be?
25.
So multiply that so we can get our base area. 25 centimeters squared times pi. Quickly calculate it up. Take out your notebook and calculate it. Now you're wasting more time because you packed up before we were finished. Kimberly, what do you have? 78 and 5/10 and the unit's going to be centimeters squared. So now we have something to substitute in for my volume formula. Which is the base area times the height. So we have to take the number that Kimberly just gave us, 78 and 5/10 centimeters squared, and we have to multiply that to the height. What's the height? 7 centimeters. And what's 78 and 5/10 centimeters squared times 7 centimeters? What's that going to equal? Makeda, yes.
549 and 5/10.
Nice. It's 549 and 5/10 centimeters cubed.